In example 3, we need to solve and justify each one of these. We've been doing a lot of justification, so I'm just going to solve these and then I'll verbally tell you what I'm doing. If you were actually to have to justify these, you would just make your 2-column chart, or you could also write a paragraph on how you solved it, what you did. For these types of problems, when we have this extra term hanging out here, the best option most times is to do the distributive property first, combine like terms on one side, and then solve as needed. This one we could actually subtract 7 from each side, that would work. But I'm going to utilize this other strategy because if there's an x here, you wouldn't be able to do much with that. So we will use the distributive property here first. Remember, when we work on one part of an equal sign, we can do things like the distributive property or combine like terms, but we can't do those things across. When we work across an equal sign, we need to add or subtract or multiply or divide each side by the same thing. So let's see what happens when we use the distributive property. We've got 2x, and then 2 times 6 is 12. On the left-hand side, we can combine like terms. The 7 and the 12 are like terms. So we'll have 19. Now we'll subtract 19 from each side. We'll have 2x is equal to 20. Divide by 2. And x will be 10. It's usually a good idea to check your work, so you can take this 10, plug it back in, and then just use PEMDAS on the left-hand side, or the order of operations, I should say, and then figure out if the left side does equal the right side. If it doesn't, then either you made an error with the order of operations, or you just found the wrong value. So 10 plus 6 is 16. 2 times 16 would be 32, and 32 plus 7 is 39. This one checks out. We'll switch up pens here. We're going to do the same thing with this other one. We'll use the distributive property first. So we've got 3w and then 3 times 4, which is 12. We can combine like terms. We have a couple constants here. 2 and 12 are constants. They don't have a variable. So we'll put them together. We'll combine them. 2 and 12 is 14. Then we'll subtract 14 from each side. And we've got 3w is equal to 13. Divide by 3. And we've got this nice improper fraction here. 13 isn't divisible by 3, and 3 is only divisible by 3 and 1. So there's nothing we can really do with this fraction. We can just leave it. You can change it into a mixed number if you'd like, but it's not necessary. If we perform this operation here, you'd have 13 over 3 plus 4. So 13 over 3 plus 4 would look like this. That's 12 over 3. That's the same as 4. Put them together, we'd get 25 over 3. But then we're just multiplying that by 3. So that this whole entire part here is just 25. And then add 2 and we've got 27. So this does work if we substitute this fraction in into this problem here in part B.